Hi, welcome back to Manohar Academy. In this lesson, we are going to wrap up what we have learned in this particular module on inheritance. We will do a quick recap, then we will wrap it up. So when we are talking about inheritance, we are actually talking about creating new classes from existing classes. As a result, the derived class will inherit all the member fields and all the member methods from the superclass. It will help us in the code reuse. Also, it will help us to remove the duplicate code. As a result, we are writing the manageable code. So whenever we have duplication, we are going to run into problems. So we don't want any duplication of code. Also, we always want reusable code which is manageable. So inheritance provides that benefit. In the terminology, inheritance terminology, superclass is sometimes referred as parent class and base class. Subclass is also referred as child class. Whenever you refer superclass as parent class, obviously subclass can be referred as child class because of the inheritance nature. Also, we can call them base class and derived class. Derived class inherits from the base class. Okay. As we said, subclass inherits all the members that are fields and methods from the superclass. Having said that, because constructors and initialization blocks are not members, they are not inherited. Also, the private fields and methods of the superclass cannot be directly called, cannot be directly accessed in the subclass, because the private scope is limited to the class in which the fields and methods are defined, and they can't be accessed even by their subclasses. Also, whenever you are inheriting some behavior or inheriting all the behavior from the superclass, some of the behavior you may not want. You want a different behavior at the time or for a particular method. In that case, you can override that method using the override annotation. You don't need to use the override annotation as far as the method signatures match exactly. So if you add a override annotation, if you are doing any mistake in the signature, then the compiler will tell you. So using the override annotation is good, but you don't need to use it as long as you know the signature is same. Also, after overriding, you can call the superclass method superclass overridden method using the super keyword. Then you can use super dot whatever overridden method is, that method name, you can use it to call the overridden method from the superclass. As a result, whenever you are overriding a method, for that method you got two different implementations, one in the superclass, one in the subclass. So whenever you are calling that particular method which is overridden, the actual method that is called depends on the object type. For example, here we have person2 and person3. But person2 is of type student, person3 is of type employee. So if you call the overridden method on person2, whatever overridden method is in student, that will be called, not what is present in the person class. Also in this case, whatever overridden method is present in the employee class is called, not what is in the person. So the version or the implementation of the method that is called will be decided at the runtime, and it will be the method that is existing in the type of object, not on the type of variable. Also, the list of methods that can be called will be decided on the type of variable, not type of object. Once the object is assigned to a particular variable type, we can call only the methods that are available on this particular type, not on the object type. Also, as we go up the hierarchy or the superclasses, sometimes they cannot provide implementation for all the methods because they can get so abstract, they will not be able to provide implementation. So a method that does not have an implementation is called an abstract method. Abstract method doesn't have any implementation, and any class that has at least one abstract method must declare itself as abstract. Also, these abstract methods cannot be private. because whenever you have abstract methods, there will be abstract classes, and you cannot create objects of type abstract class. So subclasses has to derive from these abstract classes, and they have to override the abstract methods. So for that reason, we can't have these abstract methods as private. Also, having said that, any class that has at least one abstract method, what we said is any class that has at least one abstract method should be abstract class. Having said that, a class that doesn't have any abstract methods can voluntarily declare itself as abstract class. So whenever you feel like, okay, you have provided all the implementation for a class, but you don't want any implementation of that class because you are not sure whether the implementation you provided is good or default or not. So in that case, you can define your class as an abstract class, and no one can create objects of abstract class, but you can create reference variables of abstract type or abstract class, and they can point to the objects of its subclasses. The final methods and final classes are exact opposite of abstract methods and abstract classes. So in case of abstract method, you don't know how to implement it, but in case of final method, you know how to implement it. Not only that, you don't want any other implementations for that method. So in a class, you can define one of the methods as final methods, and subclasses cannot override them. Subclasses cannot hide them. They have to inherit whatever implementation you have provided for this final method. Also, you can declare a class itself as final. In this case, there can't be any derived classes for these final classes. We have the math class, string class, local date class. All of these are final. No one can derive subclasses from these classes. These classes are so important. The compiler want to make sure there are no other variations for these classes. So we define them as final classes. Also, we said that in SuperClass there can be private variables or private fields, and from the subclass you can't access them. So in order to set them, either you have to use their setters if they are provided to set the private variables or private fields of the superclass, or you can call the SuperClass constructor, which can in turn set those private fields. So, and sometimes the superclass will not have default constructor. In order to make sure the superclass constructor is invoked rather than default constructor, in these cases you should be very careful. So also in every class, in every constructor, this particular statement should be satisfied. That is, in every constructor on the first line, you should call a different constructor in the same class using the this keyword, or one of the superclass constructor using the super keyword. So this is very must. So every class, in every constructor on the first line, you call the constructor of the same class or a superclass constructor. Whenever the superclass doesn't have default constructor for the reasons that I have mentioned, then the subclass should define the constructor. Subclass cannot depend on the default constructor provided by the compiler. It can't do that. It has to define its own constructor and call superclass constructor explicitly. Because the superclass doesn't have a default or the no argument constructor, the subclasses has to do this. They have to define their own constructor and call the superclass constructor. Also, at the root of all the hierarchy lines, we have a superclass called object. So every class that we are declaring or defining, they all directly or indirectly inherit from the object superclass. As a result, we are going to inherit all these methods. So every class is going to have all these methods, and the 5 methods that have wait, notify and notify all method names, they are used in concurrent programming. And these methods, clone is used to create the clones for a given object from a given object, and finalize is a method called on each object before that particular object is garbage collected. Also you can call get class so that you will know the class name at the runtime. So these three are not that frequently used, and these five are used only in the concurrent programming. But these three, the toString method, equals method, and hashcode method, they are used frequently. Coming to toString method, it is very simple. If you don't override the toString method, then whenever you are trying to print an object, you get the message that is the fully qualified class name followed by some hash code, and this is not informing us about the state of the state of the object. If we want to know the state of the object, we want to print something meaningful, so we can override the toString method and we can return a string that represents or that can convey the message about the state of the object. So you can create a string that has the values from the fields, then you can return that string in that toString method. It is very simple. Coming to equals and hash code, before that we need to understand what is the difference between value based classes and regular classes. The value based classes are something like dates, years, money. So we don't need to depend on the identity of the objects to see whether they are equal or not. We can simply compare their states. We know that we can compare two objects either by their identity or the state. So the value based objects, mostly their comparison or their equality depends on their state. If their state is same, they are equal. So the good example is date. So whenever we are overriding these equal methods, we also have to make sure we are following some rules or the contract for the equals method. That is, it is reflexive, symmetric, transitive, consistent. So this is very simple. A should be always equal to A. That is what reflexive is. A object should be equal to itself. Symmetric. So if x equal to y, then y should be equal to x. Transitive. That is A equal to B and B equal to C, then A should be also equal to C. Consistent. It should be always consistent. That is expected as long as the state doesn't change, it should return the same values. Also the null values should be treated appropriately. So if you are passed a null, then you should return false. So this particular implementation here, it is taking care of all those things. Generally we follow these particular steps. If the received object is null, then we return false. Then we check for the identity. If they are same objects, obviously they are same, so we return true. Then we check for the class type. Should the received class of the same type as the actual class? So we can check that using the get class on the current object and the received object. Also sometimes they can be of different types. They don't need to be of same class, but the received object should be of particular type. So we can check that using the instance of. After doing all these, we can typecast the received object to whatever object type we need. Then we can compare all the fields field by field. So all these things should be taken care whenever you are overriding equals method. Also hash code has a contract. That is, whenever two objects are equal, they should return the same hash code. It is very important. Whenever you are overriding equals method, you have to override hash code method in order to obey this particular contract. That is, if two objects are equal, then they should have the same hash code. Now we also have one extra access modifier that is protected, that is closely related to the inheritance. So we know that the private scoped variables, they are accessible only inside the class in which they are defined, and public fields and public methods, they are accessible everywhere. And package scoped, that is default, if you don't provide any keyword, they are accessible only inside the same package. The protected is somewhere between the package scope and public scope. they are accessible inside the same package, just like package scope. Also they are available, or they are accessible from the subclasses in different package as well. So here we can see that we have a protected variable, and this can be accessed in other classes in the same package, so similar to package scope. Also they can be accessed from the child classes or the subclasses in different package. So the protected access is related to the inheritance. Even though they are accessible inside the child class, in order to protect this particular encapsulation principle, they cannot peek into the private fields of the parent class. So in this particular child class, if you receive any parent class objects, you can't access the protected fields inside the parent class. You can access the protected fields inside the child class or whatever that class is. You can't access private fields of the parent type. Okay, having said that, the protected fields are less common, because we have this problem with inheritance, and even though they are accessible inside the child class, you can't pick into parent class objects. So it is not that useful, and it maybe someone can abuse this one by just creating the subclasses, and they will have the access to private fields, not of parent but their own. So we don't want that. So protected fields are less common, or very less common, but protected methods, they are common. So you can trust the child class or the subclass to know how to call the protected methods directly or properly. So whatever preconditions has to be satisfied before calling this method, the subclasses are supposed to know. So protected methods are okay, but protected fields, they are not okay. Also at the end, we have learned about arrays and how they deal with inheritance. So in an array of subclass type, you cannot add objects of superclass type. For example, if you have array of students, you cannot add a person object inside that, because that person object may be referring to a employee object, not student object. So inside a array of subclass, you cannot add a object of superclass. If you are able to do that by using the superclass array variable, then at the runtime we are going to get array store exception. That is all about the inheritance concept and inheritance module. So we wrapped up inheritance. In the next module, we are going to look at a very important concept that is called interfaces. So that is very, very important, and they are used very extensively. So also to follow proper design patterns, you need to understand the interfaces thoroughly. Okay, that is all from my side. Last but not least, if you haven't subscribed already, please go ahead and subscribe. If you are benefited from this video, please make sure you like it and you share it with your friends so that they can also watch, they can also learn. See you in the next lesson. Thank you.